Hello and welcome to Physics Teacher. I'm creating a new set of tutorials to help students with their grade 11 math functions course. In each tutorial we're going to go over a certain topic of problems and how to solve them, as well as how to use your TI-nspire graphing calculator to help you. If you prefer to use Desmos, you should check out my channel, and under playlists as I have many tutorials for how you can use Desmos as well. Today's topic is domain and range. Let's get started. Alright, so we're going to find the domain and range for these three relations. Let's start with the first one. So the first one, that's a linear relation where the y-intercept is going to be -5. So let's just roughly graph that here. And then the slope is 2, so we'll just roughly make a nice steep slope here. Now we can see for linear relations, this line is going to extend forever to the left and to the right of our x-axis and forever down and up on our y-axis. So for the domain, we write it with these swirly brackets to represent set notation, and we say that x is an element of real numbers. So x is any real number. If you don't remember what real numbers are, check out my tutorial there, and in less than 60 seconds, I'll explain to you our number system. Now, our range is for our y coordinates, and just similarly as our domain, use our swirly brackets for set notation, and we say y is any real number. All right, let's try the second example. This one's a quadratic, and if you remember from grade 10 math, it's already in vertex form for us. So it's telling us where the vertex is, which is at the coordinates 1 and 3. So somewhere around here. And it's also a quadratic that opens up and is not stretched or compressed. So it's going to look something like this. Now, similarly as our straight line, our domain, or the x values, extend forever to the left and to the right. So we can say that x is any real number. However, if you look at the range, you'll notice that this quadratic never goes anywhere down there. Okay, below that minimum point, you never see any location where that function exists. So we're going to start by saying that y is any real number, but we have some conditions. That this function only exists when the y value is greater or equal to 3. So we're going to write y is greater than or equal to 3. All right, let's try our last example. This is an inverse function. And in math, we are not allowed to divide by 0. So you can see right here, if x were -3, this would be 0. So x cannot equal -3. This leads to what we call an asymptote. And we can draw that asymptote on our graph here at x approximately is equal to -3. So our function's never going to touch that line. Now we have another asymptote at y equals 0, because we notice if you have 1 divided by any real number, you'll never get 0. So right over here at y equals 0 is our other asymptote. Let me change this one to red as well. That'll be our do not touch line. So our function looks something like this, as it goes on forever but never touches those lines. So we can write our domain and say that x is any real number with the exception that we've already written here, it cannot be -3. And we can do the same thing for y in our range, where y is any real number except y cannot be equal to 0. So there's our domain and range. Let's use the TI-nspire graphing calculator to learn how to graph a function and figure out where the maximum or minimum of that function is. So we're going to start by adding a graph to our new document. Then we can type in the function. And when we're done, we hit enter. That's not a good view of the function. So to change our view, we're going to go to menu, and we're going to go down to number 4, which is Windows/Zoom. From here, we can choose a fit, or I can choose Windows Settings 1 and choose that fit myself. So I'm going to choose it myself, and I'm going to choose our x-axis to go from -2 to 10, and our y-axis to go from -40 to 100. That looks a lot better. From here, we can determine the maximum by going back up to menu, and we're going to choose 6 for analyze the graph. From here, we can choose, we clearly see it's a maximum, not a minimum, so I'm going to choose 3 for maximum. So once I've selected maximum, I can choose where I want, within what area I want it to find a maxima. So I'm going to go from here to here, which I know where the maximum is going to be. And it says the maximum has the coordinates of 4.08 and 83.1. So now that's going to help me write our domain and range for this function. So our domain for this quadratic, as in all other quadratics, we have x as any real number. But our range, since our function cannot be anywhere above 83.1, we're going to say the range is for any real number of y, with the exception that y must be less than 83.1. If that tutorial helped you, leave a like and make sure you subscribe so you don't miss any more tutorials.